All right, so what is big data? Here's a little piece by Ed Dumble here. It says big data is data that exceeds the processing capability of conventional database systems. There's a little graphic here talking about worldwide data created and replicated in zettabytes. You see that number's growing quite rapidly. It's picking up now. Now, from an analytics standpoint, I think Ed's statement there is good, but maybe not necessarily entirely relevant. It doesn't have to be databases. Extending this a little bit, I'll add this statement. Big data is loosely defined as any data set so large and complex that they become awkward to work with using standard statistical software. Again, there's my bias. But if we want to do analytics, if we want to analyze data, big data is just the sort of data that I can't do the way I've always done before because I'm having trouble with it. Now, how big is that? Well, it depends. If I'm running on a 386 computer, it's not a real big set of data. If I'm running on a Hadoop cluster, it's a different thing. But there's always going to be big data, and that's just data pushing the limit of what you can currently work with. All right, so I said Hadoop. Does big data mean Hadoop? What do you think about that? Who thinks yes? Does big data mean Hadoop? Now, I will put on my little sales hat. Any person I sell to thinks big data means Hadoop. So my short answer there is, well, no, big data doesn't mean Hadoop. The longer answer is, well, maybe big data does mean Hadoop. Hadoop adoption in companies pretty much means that big data is going to mean Hadoop. That doesn't mean it's the only way to do it, but companies tend to buy this. Companies tend to go this way. That's what people buy. Well, they want you to use what they buy. So more than likely, big data is going to, at some point, mean Hadoop. All right, so analytics. What are analytics? And I think that's maybe a silly question. You think, well, I know what analytics are, right? I'm going to put my own definition. Yeah, I'm giving a presentation. I can attribute things to myself, I suppose. And that is, I think analytics is the combination of mathematical, statistical, and heuristic techniques to glean useful insights from data and implement actions derived from those insights. That last piece is my view on what makes analytics a little broader than maybe current terms like data science. Now, that being said, let's talk about data science. Current buzzword is data science. Everybody needs to be a data scientist. I was a statistician yesterday. Today I'm a data scientist, right? I still identify myself as a statistician, albeit I often preface that with I feel like I'm a really bad statistician because I just tend to do things in non-statistical ways and those heuristic things that statisticians don't like. But I think that even if I don't agree with that nomenclature of data science entirely, because my reasoning there is pretty clear, I think, who really goes about any sort of analytic work with scientific method? I certainly don't. Maybe you form a hypothesis and test that. I'd like to think I did that, but I don't do that. So I might be better called a data engineer if you wanted to use that word. But anyway, I think the current definition of data science is good enough to act as a surrogate for what I'm talking about. In general, we're talking about hands-on, doing analytic work, dealing with data that's large, dealing with data that's messy, and bringing that information together and then making it actionable, doing something after that. Now, the last bullet there, I think the important takeaway is whatever word I want to use to describe what we're talking about, analytics, data science, statistics, call it what you like, you have to do it with something. Has anyone ever seen the TV show Numbers? Yeah. This is my favorite thing about Numbers. He always talks about doing things like a principal component analysis. He writes on a board. Okay. If you do a principal component analysis on a board, more power to you. But more than likely, you need to use something like R or Python or SAS or database, Hadoop, that sort of thing. Those are the sort of things that you need to be able to do, not writing on a board. All right, so what is R? And there were a few people that mentioned you'd used R, a few people with interest in R. R is a few things. It's a platform. Now, we could start off by first saying it's a language. It's a procedural language for the most part. I don't know if I say this. It's more functional. This is a slide someone gave me, and I don't agree with that. It's functional language for statistics, really. So, I mean, if we're wanting to do analytics, that's its goal. There's that argument going on the web. You can see, you know, should I be using Python? Should I be using R? I don't care about that. You know, if you start using Python, that's great. More power to you. Anyway, I spoke of my bias. Here's my bias. I use R. Now, there's lots of really good visualization in R. There is an open source project associated with it. Lots of really nice stuff that comes out of that. There's a really big community, and this is a number that we bandy about, not only my company, but other people too, 2 million R users. This is a difficult number, right? How do you know how many people use anything that you don't really track who downloads it? How do I know who downloaded it when you could have downloaded it 20 times yourself? A lot of people use R. We can use some other evidence, and that is that in addition to active user groups, and that is there are quite a lot of very active user groups. The user group here, we have about 250, 260 members. We've been around for almost 6 years. The user group in the Bay Area has like 2,000 members. They regularly hit the limit on how many people they can have at a meeting, and their meetings are like 200 people plus. Now, the same thing is true for the New York users group. There's, what, 1,500 people there. You mentioned, you know, Q. The Chicago user group is pretty good too. Q, Ethan McCallum, Paul Teeter up there, good user group. There's a lot of good user groups across the United States. So even if you're not in Atlanta, if you are interested in R and you're not in Atlanta, talk to me. More than likely, I probably know who runs your user group. And if not, we as a company probably fund your user group, so I could probably put you in contact with them. All right. The other piece is that in addition to just the base language, it's what I'll say an ecosystem. There are 5,000 plus, I think I looked at this morning, 5,234 packages. And this is just extensions written by people in the community to make R do something different. As with any other language, you can find packages that do things that are, let's be nice and say, not the best idea. Completely stupid and silly is what some of them are, but it is a language, so you can do whatever you want with it. Now, there are ways to scale up R to big data. I mean, I mentioned Hadoop. Ignoring what I'm going to talk about in a minute, I can write MapReduce jobs that use Hadoop. I mean, using R, because R actually will take standard, you know, input and output there. So I can actually just write a MapReduce job in R. There are a lot of packages out there that try to ease that. Things like Repay, R Hadoop, which is a open source project we started with RMR. But to scale it in general, you have to do something. You have to make it scale. It just doesn't scale on its own. All right, just a quick pick. That's a picture of some of the user community. I ask anyone used R. Has anyone been to any of the Use R conferences, international conferences? No. If you want to use R, and let me say this, if you start using R and think you're really good at R, go to one of these conferences, because you won't continue with that thought a whole lot longer. You could see a lot of the people that wrote R. I will say this, in that I'm a good R programmer. I'm pretty solid. When you go and talk to the people that wrote the language, they put you in your place a little bit. Not intentionally, but you know, you feel it. They know what they're talking about. But anyway, these conferences are every year, International Use R conferences. I think I've spoken at 4 of these. And just a little bit of more background on my bias. 3 of those times were how to get rid of SAS and start using R at a company. That's really well taken at a conference where people like R and don't like SAS. All right, so a brief history here. In 1993, a project was started with Ross Ahaka and Robert Gentleman. Do you see the the pattern in the names there, R and R. That's why it's called R, if you ever wondered. It is a dialect of S, or a offshoot of S. And so they thought, well, we'll try to use a letter somewhat close to S. And since their name is Ross and Robert, they picked R. Subsequently, you know, Google came along, and it's near impossible to search for things with a single letter, and you wish you'd called it something different, but it's R. Just a quick plug. Robert Gentleman actually sits on the board for the company I work at. Ross Ahaka, being a pure open source purist, I do believe thinks we are possibly the devil. But, you know, differences of opinions. In 1995, they released the open source software, and I'll say this, in 99, I think it may have been just in 2000, right about when 1.0 was released. I actually met a few of the core group. They came to a conference that I was at and gave me a lot of grief because I didn't use R. I used MATLAB at the time. And well, in 2000, at 1.0, R was really not very good. It had potential, and like lots of things probably have potential now that aren't R, but it takes time for that potential to actually change into usefulness. So, 2004 was the first International User Conference in Vienna, and then just last year, 3.0 was released. They're on sort of a yearly release cycle now, which is pretty good because they think they've sort of reached a point where they're fairly standard on things, so things don't change a whole lot with each release. R is free, open source. Under GPL, like Linux, free as in beer, free as in freedom. That's a nice thing, right? You can do lots of things with it. You can do whatever you want with it. Those silly things I mentioned about packages, well, you can do whatever you want with it, and that's nice. It's quite flexible. It's open for integration, which means I can use it to integrate with proprietary things like SAS or SPSS or Excel. You don't see quite as many of those because quite a lot of the people in the open source community don't necessarily really care about that. There are a few, but not everyone. And there's a really broad user base. And I think this is a better measure than our 2 million plus users, is that you look at any analytic program in any university across the United States, and almost all of them are teaching their students to use R. Why? Because it's free, and you can have them do the work. They know something, they can download it themselves, and can go on with that. So that means there is a growing population of people that actually know R. That popularity is translated into some numbers here by a fellow by the name of Robert Munchin, Bob Munchin. If anyone's ever heard his name, he always publishes these pictures about how R is blowing up and you know, hits on Google Scholar, that sort of thing. Now, I think you can maybe, with a little work, discredit some of that, but you look at Stack Overflow and other things like that, there are an increasing number of questions surrounding R. So R is growing in popularity, even if this is not the 100% most accurate graphs. All right, so why is everyone not using R right now? And I really like this. It came from a user group meeting out in the Bay Area, and that was from a fellow from Google by the name of Bo Cowgill, and it says the best thing about R is that it was developed by statisticians, and the worst thing about R is that it was developed by statisticians. My bias, clearly I like that, but I do certainly understand not everyone thinks that way, and that is the way I think, so there are things that you have to deal with sometimes. To that point, I'm going to bring up one challenge, and then I'll mention something else, and that is, so here it is. Other than that, R is great, right? Other than the statistician piece, if I can get around the fact that I have to think like a silly statistician, that's great, right? Well, some people have used R. Have you ever run into issues with R? Anyone? Yeah? Just one hand. You haven't used R enough if you have only one issue. Has anyone ever seen this error right here? I knew that was the issue, right? Everyone runs into this error. If you have not run into this error, you did not use R enough, because you will run into it. It just happens. R being built by statisticians means that their goal is computational accuracy on most things. Their goal is not efficiency. Their goal is not, let's not make 25 copies of the data. Their goal is not, let's make this work on any size data. They don't care about that. Very clearly, by a member of our core group, we had asked the question about, well, why don't you make R so that it scales up to big data? Their answer was, I don't care anything about that. So, you know, they are really statisticians and are often working on what they may term big data, 1,000 observations. They don't care. Now, that being said, that doesn't mean everyone doesn't care. It's just the people who are in control, holding the reins, don't necessarily care. All right. Who here has more than one core or processor on their machine? Hey, surprise, surprise, right? Or single-threaded. Who's ever used our help? Anyone? I apologize profusely to you, right? Here's just two little statements off of our help. Brian Ripley is the one who has the, I guess, the most notorious person on our help for if you ask a question and you do not ask it properly, you will receive, 10, 20, 30 replies about how you should have asked that question. None of which will address your question. All will tell you how you should have asked that question. Now, that being said, the people answering the questions on our help are the core group. They're the ones who wrote R. They know how to answer your questions. They're smart people. It's a good group of people that is freely giving their time. So even though they may be a little bit surly, going to tell you to read the manual, well, I can somewhat understand that. But let's just say that if you ask a question and you do not very clearly conform to the posting guide, you will receive a lot of replies, I won't call them answers, about how you should have asked that question. All right, so that brings me to, well, what is Revolution R Enterprise? I mentioned it, again, that I work for a company called Revolution Analytics, and we actually build a product on top of R. A lot like Red Hat does with Linux, a lot like Cloudera does with Apache Hadoop, that sort of thing. Let me give some motivators first. Why do we need it? And I mentioned them before. R is memory bound, right? And it often does silly things. If I fit a regression model, it actually holds the original data in my regression model. It'll probably make copies of it 10, 20 times while I'm making that regression model. And it's in there. So, if my data is quite large, it tries to do silly things for me. There are some ways around some of that, but not completely. Speed. R is single-threaded. If you've got those 4 cores, you've got the 8 cores, you're ready to get off and go running, well, R still only wants to use one of those things. The other is that community support. Now, community support is good in general, right, so long as you know how to ask those questions. Now, I don't want to completely disparage it because there are some very smart people who are involved with the R community who will answer your questions a little bit nicer, just not on our help. Go to Stack Overflow. There's about 3 or 4 guys who don't use our help who are well known in the community. They are better at answering the questions. Now, if you ask a question like, I tried to fit a regression and it didn't work, you're going to get a lot of replies about, well, that was stupid, and you didn't tell us what didn't work, and that sort of thing. So still, you have to answer your question. You have to ask your question properly, but at least there are a little bit nicer people to answer them. Now, there are some positives, right? And that is there are 5,000 plus packages out there. There are a lot of things that are good and you want to make use of. Pick an analytic technique. If I want to go implement that technique somewhere, there's probably an R package that does it. So that's a good thing. One other piece, and this is often more just from a company or enterprise standpoint, is that a lot of companies, and I don't care what they say about we support open source. Supporting open source and letting someone in the company use an open source product, sometimes are very different things, right? Sometimes companies really just like the fact that someone's on the hook in case something goes wrong. Cloudera, Hortonworks, those sort of things. Not to say they don't add anything, they definitely add something good on top of Hadoop, but a lot of times all you care about is there's somebody I can call, there's somebody I can, direct something's not working to. So sometimes the positive of open source is a little scary to companies. So what we do with Revolution R Enterprise is we actually develop a collection of algorithms and a framework for dealing with large data. We do this with a hybrid, what it says, memory and disk scalability. The interesting thing is, and I didn't put any timings up here because I'm trying not to be salesy as much as I possibly can and still talk about a product you have to buy. But we have timings that are in my opinion, just amazing. Timings that actually a lot of the companies that tout their in-memory analytics, we can do things faster off of disk than they can do in memory. Now, I'll attribute that to some smart people that wrote really good algorithms that are written really well. But the second piece there, parallel threading. Everything in Revolution R Enterprise that we've written actually is written in such a way to run in parallel, either over multiple cores on your local machine or over a parallel compute context. And I'm going to glaze over a few of the others. Of course, we offer support. We have the ability to use any of the open source R packages, and there's a commercial license, open core, much like something like a Red Hat. Excuse me. All right, so what is Revolution R Enterprise? It's a few things, but if you look at this box sitting up there, this is Revolution R Enterprise. If we start at the left, you can see we have R and CRAN, and really the reason we put that is that we at our core are open source R. We take open source R and then we actually just add things onto it that makes it more usable for you for big data. The positive there is that if you've been using the open source R, you want to make this move, well, you don't have to change any of the open source piece. Now, granted, all that stuff that you did prior is going to have the exact same problems. If you ran into the can't allocate vector of size, whatever, 2 gigabytes, you'll still run into it if you do things the exact same way. But there are facilities for dealing with it. Excuse me. So really, enterprise readiness, high performance analytics, multi-platform architecture, data source integration, development tools, and deployment tools. Talk about a few of those pieces. So I mentioned what is R plus CRAN. Revo R is really just the layer that we put on top of CRAN. Really, all open source R. All we've done is recompile open source R with the Intel math kernel libraries. Out of the box, what this means is that you get multi-threading on your linear algebra. Now, disclaimer, you can go do this yourself. It is detailed in one of the PDFs that you get with R about how to use a different linear algebra library. Now, it costs $500 to go get the Intel math kernel libraries, and then you have to do all the work yourself. So there is something positive here, right? There's a little value add above just the price of the Intel math kernel libraries, and that it's all done for you. Now, there are open source alternatives, various other parallelized linear algebra systems. But anyway, this is step one in making R a little bit better for dealing with data that's large. Because if you think about it, how do I deal with big data? You think it's good enough just to be able to process it? Well, if it takes me, a month to process data, that's great that I can actually do something, but is a month fast enough, right? So there's two things I really need, and that's the ability to process it and the ability to process it in a time frame that actually makes sense for what I need it for. Pardon me. Excuse me. Okay, the next piece, and this is the one I always struggle with because a bit of this is what I will term marketecture. There's 3 boxes there, yet they're really all just one thing. And they all come in a package that you use on top of Revo R called Revo Scale R. So the added black text at the bottom is mine because I don't like dividing things up that aren't actually separate. Anyway, from a functionality standpoint, what we have here is the ability to connect to various data sources, the ability to distribute your work over various parallel backends with distributed R, And you can see some of those there. Windows servers, Red Hat and SUSE Linux servers, platform LSF managed clusters, HPC clusters on Windows. We actually can run in database on Teradata. We can run in Hadoop on Cloudera and Hortonworks. And when I say can run, I'm going to detail a little bit by what I mean by that. It's not just a matter of the software will run, it's a matter of it actually running easily on those things. Now the secret and important part, secret sauce, I guess, is the scalar piece. And that's the collection of algorithms that have been rewritten. They're rewritten to operate on data in chunks. It is a paradigm very similar to something like a MapReduce paradigm. It's not MapReduce, but if that helps you, at least it helps to think that I'm operating on pieces of data. I put all those pieces of computations together at the end, and I end up with something. Last two pieces, which is not that incredibly important to big data, I'll just mention them quickly, is just the ability to connect to some sort of web-based front-end or .NET or JavaScript and an IDE. So I'll skip over those for the most part. Now, I think this is the big strength that I want to talk about. Is what we call write once, deploy anywhere. The thing is that when you utilize the code that we've written for RevoScalar, I write my code to do a task, let's say linear regression. I write a function that calls linear regression. If I want to run it locally, I just run that piece of code I wrote as is. If I want to run it somewhere else, well, guess what? That same piece of code is the exact same code that runs somewhere else. I don't have to break it up. I don't have to do pieces. I just have to tell it where that work needs to be done. And I think that's a really neat part, because though Hadoop is a real powerful tool, let's just say, and I don't believe this, I don't believe what I'm going to say, so give me a little leeway on what I say here, is that let's just say that in 2 months, Hadoop just crashes and everyone says Hadoop's a big pile of junk. We don't want it anymore. What happens to all that MapReduce work that you've done there, right? Can you move that somewhere else? Well, yeah, but you got to rewrite it. Our goal here is to try to make something that you can write and use it no matter where you use it. And I think that's an important piece. And actually a piece that I think not just from us, but you're going to start seeing from other places. You're going to start seeing it on Hadoop, especially with the advent of Yarn, other ways to do things. I think you will start seeing these movements toward writing things in more of a, here's what I want to do, and it just happens to run somewhere else. All right, so a little bit on that synergy. Talent coming out of school knows R. That's a good thing. Not to say you can't teach people something new, you certainly can. I mean, if you get into this field, you certainly have to be at least somewhat intelligent, right? But if you have talent that already knows it, that's a good thing. We have a talent pool we can pull from. Revolution R Enterprise is R, which means, for the most part, people with the talent already know it. Plus some more things. Revolution R Enterprise provides a unified way of carrying out analytics, and the thing is that it doesn't matter if it's small or big, it works the same. Works exactly the same. And the last piece is that the code is portable, which is a huge positive. All right, now I mentioned that portability. Now, can everyone see that code okay? For those who have used R, let me see if I can show you here. This line right here says RX logit. If you've used open source R, you could equate that pretty much to a call to GLM. You're fitting a logistic regression. The thing is that this function, RX logit, if I were to just call this function right here, would take 6 minutes to run. This is a 1.5 billion row data set. So it takes about 6 minutes on a fairly beefy machine to run. This statement right here, where I set this compute context, what that does is tells it, I want to run this on that what's called my weight cluster. Now, my weight cluster, we don't show the definition of that, but it's just a list. If you're familiar with R, it just says, okay, this cluster is located here. The head node is this address. This or that data stored in this particular place. It's not a complicated thing. It's something you pretty much define once for a cluster. It's not like it would change. But once we define that cluster manager actually handles all of the spreading of the work for you. which is pretty nice in my opinion. It means that, native job scheduler does all the work, handles the distribution, the monitoring, the failover, which means if I have a Teradata appliance, if I have a Hadoop cluster, if I have a Windows HPC cluster, if I have a platform LSF cluster, I could run this exact same code on all 4 of those things with only one change for each. There's setting an option of telling it to do the computation in this place. Personally, I think that's a pretty cool thing. Now, I want to add one other piece, and that is that there are open source facilities for handling big data without using what we sell. There's things like a package called FF, just to mention that. Big Memory is one. Big GLM or Big LM allows you to fit linear models on big data. The thing is with those is that, and there are, do a search for them, there's some blog posts about those, most of them in response to some of the posts that we've had on our website. If you go and try to use them, you can certainly do it. They work. They just don't work quite as well, I guess, and I hate to say it that way. And they don't often work past a certain point. So the issue, my view is if we're picking some way to be able to scale, scaling a little bit more is not worth my effort, right? I don't want to. If I can operate on 8 gigs of data with open source R as is, and an open source big data solution allows me to operate on 12 gigs, but that's pretty much it. For me, it's not worth that. I just don't want to spend that effort. No, that's personal preference, though. All right, so any questions? We have about 5-6 minutes, I think. Yes? If you have a high compute.
Yeah, I have a high performance computing setup with lots of clusters, and then I have an R with the API, multi-palette code.
Right, and you have to spread. No, you can do things in parallel, but you would have to. So how would you fit a logistic regression on 20 billion rows of data on a high performance cluster using MPI?
You have the scheduler just summing this over the cluster nodes.
Right, but the algorithm hasn't been written in such a way that you can actually fit a logistic regression. So I understand what you're saying, but it doesn't work that way. It does not work that way. Now, MPI on a high-performance cluster definitely does something for you. It gives you something definitely quite good. But it doesn't mean that you can apply, and I'll term them high-performance analytics as opposed to high-performance computation. High-performance computation meaning more heavy parallelized small computation, whereas high-performance analytics are things like, let's just pick support vector machine, linear regression, things that actually require me in general to operate on all of my data at one time. MPI doesn't solve that for you. MPI gives you a platform to solve that with, but it doesn't solve it for you.
But actually, you can distribute your whole input, separate it, and then submit it over the cluster nodes, and then apply the same clustering. I think it works.
Apply the same clustering? Potentially, I will agree with you that clustering might be easy to split into pieces and to refit. But again, if we talk predictive models, it's not the same splitting my data into pieces and doing the computations and putting them together. Now, if I do sampling, bootstrap sampling, you can refer to that as some sort of ensemble. Sure, that makes sense, but you're not actually doing the same thing. My point simply being that a MPI-based cluster is actually what we use on LSF. It's a platform that enables you to do something, but it doesn't solve your problem for you.
So what you're saying is like if you can split your input, if you can split your input, then you can just use the MPI-based cluster. But if you cannot, then you should use this kind of stuff.
Sure. No, absolutely. It depends on what you're trying to implement. If you're looking to implement some sort of ensembles on sampled smaller data, you can use almost every bit of R. You just have to do the sampling. The problem is that if your data is large enough to start with and you're using R, the sampling is somewhat difficult. But if I can do the splitting, you can use, I mean, there's a parallels package in open source R that allows you to actually spread work over a parallel backend. That's there because of work that we contributed back to the open source community. We want that flexibility there, right? But it doesn't actually solve the problem. It's just a platform by which you can solve the problem.
I still don't understand what you mean by can't solve the problem because even if you can split it or you cannot split it, if you just like use some threads and then just collect output, I think still it solves the problem. I don't understand probably. I don't get it.
Well, we can talk after if you like, but in general, and I'm going to use the example, and it's a bad example because there are ways to break this up easily, but let's just say you were to fit a linear regression. An algorithm that, without some change, requires you to actually utilize every bit of the data. If I have a, let's just say I have a couple of terabytes of data. It doesn't matter if I have 20 clusters if I can't fit that couple of terabytes on a single one of those machines and do the work, because the algorithm is not written in R to allow you to do that work separately. The facility is there with the parallels package and the MPI, but the algorithm is not written in such a way to allow you to do it that way. You would have to do all that work. Now, it's not to say you can't. You absolutely can. I mean, MapReduce is the example. You can use R in MapReduce. It's just I would have to rewrite an algorithm how to do linear regression based on mappers and reducers, yeah. And I'll agree with you. I think MPI is a great, I mean, it's one of the most efficient ways. It's our fastest computation on LSF is utilizing the MPI underlying platform LSF. Other questions? All right. Well, thank you very much. And if you live in Atlanta, come to the R user group.